Hello. Today we're going to be talking about 4-5, the fifth lesson, the final lesson in chapter 4. This often has the reputation of being the most conceptually confusing of all the lessons in AP Calculus AB full stop. If you can master this lesson and this topic, you will probably do fine in this class. I can't really see a way you wouldn't. The reason this lesson is usually so hard for students is because it rolls together all of the rest of chapter 4. Everything else in this unit culminates in this part. There's also a lot of pressure to understand this because, quite frankly, there will always be an FRQ in May on this question. The calculator will not help you. It's often on the non-calculator section. This is one of the most important questions you can learn how to do. Students always freak out about this, but be not afraid. Say a little prayer to the calculus gods, and we'll do fine. Our students at Mira Mesa almost always do 4 points better than the national average, meaning the national average on this question is about 3 out of 9. Our students almost always get 7 out of 9 on this question. That does not mean it's easy. Focus. Watch this video 100 times. Watch the video after this 100 times. To try to keep this video short, as short as I can, we're going to cut this off after I go over all the terms. The next video I'll do 2 examples. I have other videos on the channel in which I do every single example in the book. I highly recommend you take this stuff really seriously. It'll help solidify everything in this chapter. Without further ado, the most basic kind of thing we can do is, in this lesson, is to take a graph of f and change it into a graph of f prime, the slopes of f. This also will be the same technique for changing a graph of f prime into a graph of f double prime, which will come later. This is really easy, relatively. We're going to just find or estimate the slopes of this function, f, and sketch a graph of f prime as best as we can. So when I look at this, I'm looking for places where it's relatively easy to get a slope. The 2 places you should notice are the points of horizontal tangency, the relative mins and the relative maxes, right here and here. Those are really nice points. Both of those would have a, trying to just draw one horizontal line. Is that too much to ask? Okay. Doable. We're talking about here and here, I have a slope roughly equal to 0. The line I didn't really draw reflected that, but we should see how they're both horizontal tangents. So at the same x value, the slope of f is f prime. So the slopes here are becoming the y values here. Since the slope at x equals -2 is 0, over here, the y value at x equals -2 will be 0. This point represents that the slope of f prime, is 0. The y value of f prime is 0, meaning the slope of f is 0. That's it. Same exact thing over here. F prime equals 0 at 2 means the slope of f at 2 is 0. The slope of f is 0 at 2 over here. That's all well and good. We're going to look for some other slopes we could use. Another point I see that's somewhat attractive is the origin. And that's because pretty much between here and here, we have a nice straight horizontal, a nice straight line. If you extended that line perfectly, I think we would all agree that it's a slope of about -1. So there the slope is approximately -1. So I'm going to graph a y value of -1 at the origin x, or sorry, at x equals 0. That's it. So now we have some sort of conception. We have to have a nice continuous function. Since this is nice and continuous, we can do one last thing, maybe over here. I don't know what you would call that. A slope of around, I don't know, 2. A slope of around 1-ish. Whatever. And this is what I mean by it's all relative. So at x equals 3.5, the slope is about, and this is what I mean by this is easier than what's going to come later. Estimating slopes is a easy way to get a little confused. It's a lot more wishy-washy than what's about to happen. I want to make sure these are endpoints, that the graph of f prime does indeed stop. Whoa. And I would give that full credit. Again, what I'm going to be looking for is people who draw arrows here. Nope. You don't know anything past these 2 random dots. And that we just have a general shape like this. Beautiful. F is increasing. So f prime is positive. That should be familiar from 4-1. F is decreasing. So f prime should be negative, 4-1. And then f is increasing, so f prime is positive once again. Concave down, f prime is decreasing. Concave up, f prime increasing. That's really all there is to graphing f prime. It's really much more wishy-washy. Do not concern about this much. This one too much. The next thing is a little harder. Antiderivatives. This may or may not be the first time you've seen this word. Undoing derivative, right? This will be a cornerstone of the last half of Calculus AB. That's an R. Right now, all we have is a graphical technique to undo this derivative. We're going to turn an f prime graph into an f graph. We're going to switch from f prime back into f. We're taking off the prime. This is a pretty simple process, but boy is it confusing. We're going to make an f prime number line by using the location or position of the points on f prime graph. Not the slopes. Not the slopes. Rather the y values. That's what we mean by location or positions. Above or below the x-axis. That's what we mean by position. Okay? Then we're going to make an f double prime number line by using the slopes. So again, f double prime is the slopes of f prime. The y values of f prime are the slopes of f. It's a chain like that. Slopes of f prime. Derivative of f prime. F prime derivative. That's why we're talking about f double prime here. Slopes of f. Derivative of f. Y values of f prime. We're going to combine information from both lines to graph f, just like in the last chapter. Sorry, just like in lesson 4-4, except with a lot more freedom. If no starting point is given, you're free to shift the graph vertically. That's because there's no way to get y values of f back, okay? Except for the starting point. So it's sort of like this one is the concavity. And you already know that from 4-3. The concavity of f has to do with f double prime. That's the slopes of f prime. F prime would be the slopes of f. So that's the slope of f. This is the concavity of f. And we combine that to get a nice picture. This will make a little more sense when you start doing it. This will make a lot more sense once you do it 100 times. You will get this handout in class if you haven't already. Here is a big master chart, it's not in the book, of how everything translates. So we see some blank rows over here. That's because, again, there's no way to get the y values of f prime by looking at an f double prime graph. The y values of f prime become the slope. If the y values of f prime are greater than 0, if the graph of f prime is above the x-axis, that means f has positive slope. That means f's y values are increasing. I don't know. Pause this, make it your screensaver. I've seen people do that before. Sleep with it under your pillow by night. The slopes of f prime are the concavity of f, and those are the y values of f double prime. That's where this guy finally comes into the picture. If the y values are above 0, if the graph of f double prime is above the x-axis, then f prime has positive slope, meaning f prime's y values are increasing, and that means f is concave up. I'm going to stop this video here. I want you to listen to this part a million times, read this chart, make this chart make sense. We will see that f has a relative min or max when the y values of f prime change sign. That was still true. Please pay attention to whether it's a relative min or max. Max would be changing from positive to negative. F prime changes from positive to negative. F changes from increasing to decreasing. Min would be f prime changes from negative to positive. F changes from decreasing to increasing. This is all 4-2. This is 4-3, a second derivative number line. And before in 4-3, we were able to use this directly to go all the way over to f. We didn't have to think about f prime. Now what's going to happen in the next two examples is you're going to be given f prime information, and then you're going to use that to get information about f and f double prime at the same time. Please listen to this video as many times as you need. Try out some problems. If you want to try out in a judgment-free zone, the first example, this is most like you could do examples or problems 1 through 4 on page 76. Okay, don't go anything beyond that. Do those 4 problems. Read this chart. Try to memorize it. You don't have to memorize this eventually. This is just a guide to help your practice. If you can't do the problems without looking at this chart, you will not do well in the test. My test or the AP test. But this is how we will translate. Points of inflection come from the relative mins and maxes of f prime. How do I find that? You would look at the graph. Relative mins and maxes of f come from places where the y values change sign. And that'll either be because we cross the x-axis or we have discontinuities. I'm going to pause it because I feel like I've been rambling about this for a while. Take this section very seriously. Good luck on those problems. Watch the next video where you feel like this makes some sense. Good luck. Have fun. Talk to you later.